In this video, we're going to be answering one of the most important questions in calculus. Should I differentiate or integrate? That's a good question. So we're going to be looking at 6 AP questions. These are from the 2010 AP exam, if you'd like to look it up on AP Central. And in each problem, we need to decide if we're going to differentiate or integrate. So, as I go through, you might want to take note of the key words that help me make the decision. Here, what I've been given is a rate. I have the rate at which snow is falling onto the driveway, given here, and here is the rate that Janet is going to be removing the snow from the driveway. The first question asks me how many cubic feet of snow have accumulated on the driveway. Accumulation is like adding things up, and so this problem calls for an integral. In the next question, it says find the rate of change. Well, the phrase rate of change indicates that I need to do a derivative for that one. In part C, it says let h of t represent the total amount of snow that Janet has removed from the driveway. We know the rate at which she removes snow, and sort of to get the total amount, we would need to do an integration. And then finally, in part D, how many cubic feet of snow are on the driveway? Well, to determine the amount of snow on the driveway, you need to start off with your initial amount, which is 0 in this case, and then you're going to accumulate the snow on the driveway, so you'll use an integral, and then you'll have to subtract the amount that Janet has removed. Okay, on to our next question. We're going to move along pretty quickly here. In the second question, we are given a data table, and the numbers here represent the number of entries in hundreds that are in a box. Okay, in part A, it says they want us to use the data in the table to approximate the rate. Well, I know the word rate indicates that I need to do a derivative. Then in part B, use a trapezoidal sum. Okay, well, a sum indicates that I need to do an integral. I notice that this is an average value integral, which could be an important thing when it comes to explaining the meaning of that integral. In part C, they give me an equation which represents the rate at which these entries are processed, and they ask me how many entries had not been processed by midnight. I'm going to use an integral of P of t to determine the number of entries that have been processed, and then I'll have to subtract to determine the number of entries that had not been processed. Then in part D, according to the model from part C, at what time were the entries being processed most quickly? Well, most quickly indicates that that's a maximum of P of t, and in order to determine a max or min value, we'll need to take a derivative and set it equal to 0. So this problem involves doing a derivative. Let's keep moving along. We have another word problem. We have a graph given, and this is a graph of the rate at which people are arriving at a popular amusement park ride. Notice it's in people per hour. The first question asks how many people arrive. Well, if I integrate the rate, I'll know the number of people, so this is an integration problem. In part B, is the number of people waiting in line to get on the ride increasing or decreasing? This is an interesting one. To know if the number of people is increasing or decreasing, I need to compare the rate at which they arrive with the rate that they're being put onto the ride. So I'm comparing two rates. I'm going to call that one a derivative question. In part C, at what time t is the line for the ride the longest? I'm looking for a maximum length, so because I'm looking for a maximum, I think that's a derivative, but then the question goes on to ask how many people are in line at that time. Well, the number of people in line, in order to determine that, I'd have to use an integral. So this problem involves both a derivative and an integral. Part D asks me to write, but do not solve an equation involving an integral expression of r whose solution gives the earliest time t at which there is no longer a line for the ride. Well, they gave this one away because they told me it was an integral expression, and if there's not going to be anybody waiting in line, I'll need to set my integral expression equal to 0. Let's keep moving along. In question number 4, we're asked to find an area. That's an integral. In part B, finding a volume, that's an integral. In part C, We're finding another volume, and so that's another integral. That one was pretty straightforward. Let's keep moving along. In number 5, notice that we're given a graph which is g prime. So we're given a derivative, and then they ask me for function values. Okay, to get from the derivative to the function itself, we'll need to use an integral. One thing to be careful about is to make sure you incorporate this initial value right here. In part B it says, find the x-coordinate of each point of inflection. Well, to get a point of inflection, I'll need to set the second derivative equal to 0. That means taking the derivative of g prime. So I'm going to call this a derivative problem. In part C, we have a function h here, and it says to find the x-coordinate of each critical point. Well, to find critical points, you've got to set your derivative equal to 0, so I'm going to be calling this a derivative problem. We have one more question here to look at. Question number 6. Write an equation for the line tangent to the graph. To write the equation of a tangent line, we'll need the slope, and so that involves a derivative. Now, I don't need to take the derivative because it's given to me here in the problem, but this still involves using a derivative. And then here, use the tangent line equation from part A to approximate. So I'm using something I've already done. But then here, where it asks me if my approximation is greater or less than, I remember a tangent line is either greater or less than depending upon the concavity of the graph. So I'll have to look at the value of my second derivative. I'm going to call this a derivative problem as well. I'm looking at the value of my second derivative. Finally, in part C, it says to find the particular solution. So in order to find y, if I've been given the derivative, I'll have to use an integral for this part. Notice that pretty much every problem on this test involves doing a derivative or taking an integral. Those are our two major operations in calculus, and that's what makes it so enjoyable. Remember, enjoy calculus!